I'm Meghamala, Assistant Professor from Institute of Aeronautical Engineering. And today I'm going to talk about operator types. So in this regard, like in Verilog, we have different types of operators. And for each and every operator, we have the operands followed with the operands. So based on the operator, kind of operator, we have the operands. So here in the Verilog operators, like we see operators perform certain tasks. So the operators, it performs an operations in one or more operands. So usually regards to the operators, certain operators, they have only one operands. And in certain operators, they use two operands. In certain operators, usually they go for the three operands like A, B, C, A, B, or simply one operand A. So here it has two or more operands, one or more operands, and within the, so these operands we can see within the expressions. For example, here if you have like AND operation, for example, so two operands will be considering A and B. So A, B are the operands and the operator is AND is a operator. So here coming to one or more operands can be considered based on the operators. The expression which combines the operands with the appropriate operators to produce the desired functions expressions. So in order to produce a functional expressions, a boolean expressions based on the operator that you are considering and as well as the operands which are pertaining to that particular operator. Finally, in order to produce the desired functions, we have like the operator and the operands are needed. Coming to the different types of operators, based on these operators already in the previous classes we have discussed, but here in these presentations we will be knowing about each and every operator. Okay, the specification of each and every operator. So coming to the first one, it's an arithmetic operator. So for FPGA, for field programmable gate arrays, division and multiplications of every are very expensive and sometimes cannot synthesize division. So here this particular sentence is talking about as we are discussing the arithmetic operators. So in while we are using this FPGA, in the FPGA usage, that is field programmable gate arrays, in the field programmable gate arrays, sometimes we feel difficult in order to do some operations, some arithmetic operations like divisions and multiplications. So here to do the operations of divisions and multiplications, it costs more. It is very expensive. So in order to reduce, or else in order to sustain that, we are going simply with the arithmetic operations. So here using the arithmetic operations, we can easily without any severe consequences, facing severe consequences regarding the expensive purpose, like it's easy to implement the division or multiplication operations easily. So if we use z or x values for this, the result will be unknown. So we already discussed about the z and x values. For suppose in the output, if you are getting any value that is z with respect to z or x, it means what? The value is high impedance value. That means what? To the extent, beyond the extent, if the value is going beyond the extent, then that value is to be considered as z or undefined value, that is x. The operations theaters treat the values are unsigned. So here in the arithmetic operations, we can see the signed and as well as the unsigned bits as well. So coming to the arithmetic operators, so these are the characters, operation performed and the example. So here first and the foremost thing is the addition operator. So addition operator, it adds the two operands. When you if you want to add any bits, so the type of operands or is a kind of how many kinds of operands do we need is we need two operands. So here B and C are the two operands and we are performing the addition. So here B plus C, which is equals to some number, and then go for the subtract. So here the character is, we represent the subtract with the minus symbol and divide with the slash symbol and the star with the multiplication, and modulus is percentile. So here this is the operation performed. So for each character or else for each operator, the number of operands we need is 2 operands. That is A and B or B or C. So 2 operands are needed in order to perform this arithmetic operations, and these are the characters: addition, subtraction, division, multiplication, modulus, and so on. So here only 2 operands. Operands will be considered as the 2 operands, and for the operator, for each and every operator, we are using 2 operands by making use of the symbol. This is the operation which is performed: addition, add; subtraction, subtract; divide, multiply, and modulus. Coming to the bitwise operator. So this is another kind of operator under the Verilog operators. So this bitwise operator is nothing but each bit is operated and the result is the size of large operand, and the smaller operand is left extended with zeros to the bigger operand size. So here if you see this bitwise operands operator, here we have the character. So as we said that the operators, it can take the operands from 1 to more. 1 or more operands can be used. So when it comes to the bitwise operator, the first one is inverter, right? So here the operation that performs is invert each bit. So for this we need only 1 operand. See here, inverter A. So here only 1 operand is used. And then go for the AND. This is a bitwise AND operator. For this bitwise AND operator, this is AND each bit. And for this, we need 2 operands. B and C are the 2 operands, and here we are performing bitwise AND operator, isn't it? Bitwise AND operator. And then this is the OR, bitwise OR operator. So for this bitwise OR operator, we need 2 operands as well. And coming to the XOR, and here it is XNOR. So this is an XNOR operator, and here it is an XOR operator. So for all these operators except the inverter, except the invert first one, the rest of all the operators we need 2 operands. But except the inverter, we need only 1 operands, inverter A. So this is for the it says that the result is, sometimes we see the result maybe in the bigger size, or else sometimes we see the result maybe in the smaller size, right? So with the zeros to the bigger and the operand sizes. So these bitwise operators usually we will be implementing, or else will make use of these operators in the Verilog in order to perform some operations. And then coming to the reduction operator. So this reduction operator, these operators reduce a vector to only 1 byte. So only 1 bit. So these operators, the reduction operators, as the name indicates, a reduction operator, they will reduce the vectors. Okay, they will reduce a vector into 1 bit. And if there are the characters like Z and backward skip 10s play video. So here it says that the bitwise operator, this reduction operator, sometimes we use just to reduce the given bits into only 1 bit. Already we have discussed about the scalars and the vectors. Scalar bits are nothing but the 1 bit. 1 bit they just stored 1 bit and they pass only 1 bit. Whereas when it comes to the vectors are nothing but the group of bits. Okay, vectors are nothing but the group of bits. So here if you observe the reduction operator, we see the AND all bits. So this is the character represented with and the operation we performed is AND all bits. So here AND A. Okay, AND A and D. So here for this AND all operation, for the AND characteristics, we are using 2 operands. And then this is NAND. Negation of AND is nothing but the NAND. Negation of AND. So not AND is nothing but the NAND. So for this NAND also, we are using two operands. Only 1 operand is used, but with respect to the operators, we are using 2 at a time. Why? Because it is a NAND. So NAND all bits. So negation of AND of that particular operand is nothing but, this is how the representation. And then OR all bits. OR all bits is OR A only. Here we are using only one operand, and also for this is for A and this is for C. So for each and every individual operands, we can make use of this reduction operators in order to reduce the bulk of a group of bits into a single bits. And here we go with this XOR all bits. So this is all, right? Group of bits are getting reduced to one bit. This is nothing but the reduction operator. And here the relational operators. The fourth one is a relational operator. These relational operators, they compare the operands and the result in one bit scalar boolean value. So here these are the relational operators. So what they do is they just relate to each other. They just compare the operands. The operands will be compared and the result will be stored in a boolean value of one bit of result will be stored. And the case equality and inequality operators are used for unknown or high impedance values. We know unknown value is Z and high impedance value is X. So here the case equality and inequality operators. So here we are talking about the relational operators, right? So in the relational operators, we might be seeing this equality and inequality operators. So here equality and inequality operators mainly will represent only to the unknown values and the high impedance values. Okay, but the rest of the operands we can use this relational operators or as a relational characteristics, but only for the high impedance values and as well as the Z values, that is high impedance values and the unknown values. For these two values, we make use of the equality and the inequality operators. And if two operands are unknown, the result is 1. So what happens is here, if the two operands, for example, A and B, if these two operands are unknown, okay, unknown values are represented with X. So if these two values are unknown, then the result would be 1. Okay, and sometimes we see the two operands will be in the high impedance values. So in such cases, the result would be 0. So here we see the characteristics of these relational operators. Most of the things like we know, we are well known of these relational operators. The characteristics, see, we know this greater than, right? So greater than, the name, the operation that it performs is greater than operation, and here A greater than B. And then next goes with the less than operator. So this is a less than operator, and here greater than or equals to, here less than or equals to. We are relating, right? We are just comparing greater than or less than equals to. And here equality is double equals to. So equality, see for this equality we see A double equals to B, which is equals to 1 bit of 0. Okay, and then inequality. For this inequality, this is the characteristics that we are, this is the character that we are using. This is for inequality. See this with respect to the equals to. So here this is how for each and everything, if you observe from greater than till the inequality, we see the two operands are used. But when it comes to the case equality, for this case equality, we are making use only one operand, that is E operand. Okay, with only with the case inequality, we are making use of only one operand, but the rest of the relational operators, but the rest of the operators, whatever it is greater than, less than, equals to, not equals to, whatever it is, for all the rest of the operators, we are using two operands, except the case equality. The case equality, we are using only one operand, that is E. And the last one is case inequality. So for this case inequality, this is the character that we are using. So here for this case inequality, we are making use of two operands. The case inequality, when if it is here we have A and E, right? So for this A, the relational operator that I am using is A case inequality. The inequality goes with the operand A, whereas here equality goes with the operand D. Okay, inequality goes with the operand A and equals to goes with the operand D. So this is all about the relational operators. So the relational operators are nothing but they will compare the operands. So here we see they are comparing the operands A and B. So if they compare the two operands, A is greater than B. So here the comparison between the operands is taking place. But here in the relational operator, except one, the rest of all the operands will have the comparison goes with the two operands, except with one case, that is the case equality. In the case equality section, we see the only one operand is present. Okay. And coming to the logical operators. So this logical operators, they compare the operands and the result in a 1-bit scalar Boolean value. So here the result will be in terms of scalar Boolean expression in the scalar terms. Not in the vector terms, but in the scalar terms. But here, the logical operators, they compare the operands. Okay, they compare the operands. So here we see the logical operators are of 3 types. They are not true, both expressions true, and one of both expressions true. So here, not true, we are representing it with this, and for both expression true, both the ampersands A and one or both expression is bars. So here, these are the examples. So this is not true, right? So this expression is not true. So for this not true operator, we use the symbol, and the rest of the things is this. Logically, they just compare the operands, but the result will be stored in the 1-bit of scalar forms. Okay, 1-bit of scalar Boolean values, but not in the vector values, but only they store in the 1-bit of scalar Boolean values. And the 6th one is shift operator. So this shift operator is, we know, the left shift, right shift, isn't it? The left shift and the right shift. So this shift operators, they use the shift operands to right or to the left. Okay, the size is kept constant, shifted bits are lost, and the vector is filled with zeros. So here, when we are shifting the bits towards the right or toward the left, we see some bits will be added. Okay, that bits would be in terms of filled with the zeros. For example, 0, 1, 1, 1. So what I want to do, do the left shift operator. So here, the left shift operator is resembled with the left shift. So here, I wanted to shift the bits towards the left, right? So I'm shifting this to 1. So what I will be writing here, 1, 0, 0, 1, 0, 0, 1, 1. Okay, that means what here, my 1 has been shifted towards the left. So here, 1 bit would be empty. So in this kind of, in this empty, sometimes like next turn is, I just wanted to shift 1 more bit towards the left. So what it will become, 1, 1, 0, 0, 1. And then 1, 1, 1, 0, 0. So as you are shifting the bits towards, for example, if you have 10 bits, from 1 to 10 bits. So if you want to shift these bits towards the left, so what happens? You will feel, you will have something empty space, right? So in this empty space, you can fill the 0. So here, all and the vector is filled with all zeros. So the size would be the same. The size is of 10 bits. So the size would be the same. But when you are shifting, the vector bits can be added, that is the 0. Zeros are the unknown values. They don't have some values, right? So basically the shift operators, we can shift towards the left and towards the right. So here the characters of the left right shift is resembled with this double arrow, shift, right? So here B is shifted to 1. That means what here, the result will be, this is a 4 bit of data, that is 0, 1, 0, 0, 1, 0, 1. So here what happens is, I want to shift the bits towards the right. So here, so it will become 1, 0, 1, 0, isn't it? So this 0 is going shifted towards the right. So here what happens, I can mark this as into, and then the next line I can go right, I can fill this space, this cross space. That means what, this unknown space with the 0. Why? Because it's a shift right? So I'm just shifting the 0 bit towards the right. Then here 0th bit is being filled over here. So it is 0, 1 0 1, that is, so 1 0 1 0, 0th bit is been filled. And then if you go for the next bit to be filled, that is to be shifted, 0 1 0 x, right? So here I just this bit will go and settle down here, that is 0 1 0 0, then 1 0 0 0, then 0 0 0 1. So this is how the right shifts takes place. And similarly, we see for the left shift, the similar fashion goes on with respect to the left shift. So here A is less than 2. So here 2 bits of shifts can move at a time. When you are shifting in the shifting operators, 1 bit can be shifted once and 1 bit can be shifted only once. And here the 2 bits can also be shifted, and the shifting can be done once or twice as well. Okay. Coming to the assignment operators. So assignment operators are three kinds of, there are 3 assignment operators, each of which performs different tasks. So here we have, in the assignment operators, we have 3 types of assignment operators. Assign, continuous assignment, this is non-blocking and blocking. See, all these 3 assignments, all these 3 kinds of assignments already we have discussed in the data flow modeling. In the data flow modeling, to represent the data, okay, we have discussed regarding the assignment. So what is an assignment? Usually the assignment operator is equals to, this is nothing but the assignment operator. So left of the assignment operator is LHS, which is equals to assignment operator, and then goes with the RHS. So usually in the LHS, what happens is, usually we'll have nets or vectors, okay, variables. What is assignment? Assignment is nothing but dumping some values onto a variable is nothing but the assignment. So here, towards the left of the expression, left of the assignment operator, we have the nets or the variables, and towards the right of the operator, we have the expressions. Okay, so in the left hand side, onto the left hand side, we will see the values which are to be dumped on some variables. For example, A is equals to 1, B is equals to 10. Okay, so here what am I doing is, I am considering the AND gate. So for this AND gate, what should I do? I am considering A and B as the operands and Y is the output. So A and B are the input, Y is the output, and my expression goes like this: A dot B is my expression, and this expressions would be given towards the RHS. Okay, A and B, which is equals to Y. Whereas here onto the left, I just wanted to give some values of these inputs, 2 inputs, A as 1 and B as 0. So when A as 1 and B as 0, my output goes to 0. So this is how the assignment operators used. So the assignment operators, under the assignment, we have discussed regarding the 2 kinds of assignments: non-blocking assignment statements and the blocking assignment statements. So non-blocking assignment statements we represent usually less than or equals to. Okay, so for this non-blocking assignment statement also we have the left hand side and as well as the right hand side. So the non-blocking assignments operators, onto the left hand side we can use the variables. It could be in terms of vectors or scalars. Okay, and onto the right hand side usually we'll see the expression followed with respect to the operators that you are considering and as well the operands. So the non-blocking assignments usually we represent the less than or equals to, and the blocking assignments are simply we represent with A is equals to 0. So when you're writing some syntax based on this blocking and non-blocking assignments, always represent that assign is a keyword. Okay, assign is a keyword that you have to represent. Assign then goes with the statements. Okay, that is A is equals to B, or sometimes A is equals to 1 and B is equals to 10, and then initial and then begin and then goes with the statements, and finally this is a module we are starting with, and finally end module. So this is how the program will be written. This kind of program will be written only in terms of assignment operators. When the assignment operators, if you are presenting any sort of assignment operators based on the expressions and the values that you are giving, variables. So these are the different types of assignment operators. coming to the other type of operators are the other operators. So these operators are used for condition testing and to create vectors. So these other operators, maximum they include, in order to just create the vectors, they include just to go for the conditioning for the testing purpose. Okay, to test a particular device. Okay, usually we go for this other operators, and the other operators include the condition testing, concatenation, and replicate. So we know about the concatenation. Concatenation is nothing but clubbing of two sort of things. Okay, if you want to count and if you want to add. Okay, if you want to count, for example, I have A is equals to 10 and B is equals to 20. So I wanted to concatenate of these two. So what I should do, usually concatenate, in order to concatenate two things, we must represent that concatenation in the flower braces. So here I can write concatenation of count and sum. Concatenation of both. I'm just counting A as 10 and B as 20. My counting is over, and then now I'm just summing up. Okay, so what I'm doing here, I'm just adding two bits, A and B. That is, I'm counting and as well as I'm summing the bits. So here I'm concatenating the two things, that is counting and as well as the summing. So this operator in the Verilog, when you are in the developing of a module, when you are developing some module, in order to develop the module, if you are going through any sort of adding, or else if you are going through any sort of omitting something, then the best way is to go with the other operators. The other operators are include the concatenation. If you want to add something, then you can use this other operator of concatenation. And then the replicate. Replicate is nothing but it is exact the same as something else. So here, in order to represent the replicate operator, the double flower braces is the symbolic representation of this particular replicate operator. So only one flower brace is nothing but the concatenation, and if it is double flower braces, then it is a replicate. So here in the example, you can see the replicate of 2 bits, okay, 2 binary bits. The replicate of 2 binary bits along with the 3 is nothing but the 6. How come? Why? Because here 2 bits, 2 bits of 2 bits, 2 bits of 2 bits. So here totally 3 bits, right? So I'm just relating it with the 3 is just replicating the 2 bits of 2 bits of 2 bits of binary bits. I'm just adding, replicating, or else I'm just relating it with respect to the 3. I have 3 2 bits of 2 binary bits. So totally I have 3 2s are 6 binary bits. So here, in order to replicate the bits, okay, redundancy, replicate the bits, this is how the representation, the flower braces, double flower braces is used. And condition testing. So for this condition testing, the operator that we are using is the question mark and as well as the colon. So the question mark and colon together, these two operators together is meant for the condition testing in order to test something, okay, and that testing, if it is based on the conditional statement, conditioning statement, then go for the condition testing. So this condition testing, see here in the example they have given condition test, okay, condition test question mark. There's a condition, right? So if true, do this, or if not, do this. So here we have a condition, okay. So now we want to test this. So this is nothing but the condition testing, and this condition testing goes with respect to the question mark and the colon. If so and so, go with the question mark. If not, go with the question mark. And finally, with the colon. End of this statement is with the colon. So the other operators will just help us to concatenate, and these operators will just help us in terms of conditioning. Okay, sometimes when you are developing a module, you have to face some conditions will come across, right? So in order to sort out such kind of conditions in a very little span of time, then better thing is you can go for this other operators, and in that other operators, the best thing you can go with this conditional testing, okay, and then replicate and as well the concatenation. So the best way to make utilize of these operators when you are performing some action based on the developing of a module. And then the other operators goes with the operators precedence. So here this is operators precedence. This precedence is nothing but this is the order of table tells what sort of operations is made first. So here based on the priority, okay, based on the precedence of the operator, which operator is comes first, and then the first one has the highest priority. Obviously here we are talking about the operator precedence. So which operator has the highest priority and which one has the lowest priority can be easily known with this particular table. Okay, the bracket can be used to override the default. So here we have the bracket. In this bracket is nothing but it just tells us to override the default. Okay, and now we will look into it. The operator precedence. See here we have the unary operators, binary operators. So these are the unary operators. Unary operators are nothing but we can add 2 bits. In order to get one output, we can add 2 operators. With the help of 2 operands, we can see here, for example, he has given plus, minus, okay, and negation and the exclamation mark. So this is nothing but the this is AND operator, OR operator, and here this is nothing but the conditional operator, okay, conditional operator, and the bitwise negation not operator, bitwise not operator, okay, negation operator. So here these operators have the highest precedence. Why? Because here we use 2 operands in order to add the bits. Okay, in order to add 2 bits for this AND operator, we do is A plus B, right? For example, I have A as 2 and B as 1. Okay, so A as 2 as B as 1, then I have to add A plus B, isn't it? This is goes with the addition operator, and then similarly goes with the minus subtraction operator, and then the conditional operator A and B. That means what? If this is true, if not this is false. Okay, if this is true and if not this is false, and then goes with the negation. For this negation we can take only one operator, either negation of A or else negation of B. Okay, so this operator goes with the highest priority. Okay, so that means what? The highest priority operators that we can use is AND, OR, conditional operator, and as well as the negation, that is not operator, and then goes with the binary. So for this binary operator is plus and negation. That goes with the shift operator, that is left shift or right shift, and then goes with the shift operator as well with respect to the assignments. Okay, here we have the assignment operator as well, and here these are nothing but the case operators, right? Case negation, isn't it? In the previous expression we have discussed, right? Here, so this is a case equality. Case equality is equals to equal relation operators. So equals to are nothing but the case equality. So 3 double equals to is nothing but the case equality, and the case inequality is negation with respect to double equals to. Okay, so these are nothing but the relational operator. That means what? The relational operators goes the second lowest priority. Okay, second lowest priority. See the relation operator. This is first, second, third, fourth, fifth, sixth, seventh. Seventh lowest priority goes with the relational operator. Okay, and these are the bitwise operator. Shift operators, relational operators, logical operators, and the conditional operators, and the replica operators, and as well many things. See, many sort of operators we have studied till now, right? So all these operators based on the precedence, we can say the AND, OR, AND, subtraction, conditional, and as well as the negation operators, they are the unary operators. The unary operators goes with the highest priority. Okay, and then the second highest priority goes with the binary operators, and likewise finally we see the conditional operators. These are the conditional operators. The conditional operators goes with the lowest precedence. Okay, the lowest precedence goes with the conditional operators, whereas the highest precedence goes with the unary operators. So this is all about the operators, and especially the operators will help us to check whether the module, the developed module is working in the proper way or not. With the help of these operators, we can easily sort out. Okay, we can easily sort out the obstacles, and we can easily get out the output. The desired output can be easily done with the help of these operators, and all these operators are firmly used in all sort of the circuits that you are designing, whether it is a logical operator, or whether it is combinational circuits, whether it is a sequential circuit, all sort of digital circuits. The designing in all sort of digital circuits, all these operators are help us to know, or else help us to get the output easily. Okay, and using the operators, there are many advantages, like the time constraint will be reduced. The time can be reduced. The speed can be increased. The maximum, we can see the maximum speed. Okay, and we can see the simulation speed. The simulation part goes also the swiftness in the simulation part, and as well as we can see the less errors. The occurring of errors can be seen very less by using these operators. Okay, and there are many advantages by using these operators, and these are the different operators that we can see in the Verilog primitives, as well, by making use of different operators. So this is all about the operators in the Verilog. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.